Hey, I wanted to add a short addendum to the previous video. In particular, I thought I should mention that although we were calculating the phase angle in degrees based on the time difference between a reference waveform and the waveform of interest, and we used the equation phi equals plus or minus delta t over t times 360 degrees. That gave us the phase in degrees, but we can also calculate the phase in radians by multiplying by 2 pi instead of 360 degrees. Now, the reason I want to mention this is if we look at the two example problems, we calculated a phase angle for this first waveform of plus 36 degrees and the second waveform minus 30.6 degrees. And technically, there's a slight problem in that we're mixing degrees with radians inside the argument of the sine function in both cases, because 2 pi 1000 t gives us radians, and 36 degrees, they don't quite match up when you're evaluating the sine. So technically, if we wanted to use this equation to calculate the value of the function at any point in time, we should express the phase angle in radians. Likewise here, and because this waveform has a peak amplitude of 500 millivolts, I should have a little m here to fix that, as the cat was complaining about in the previous video. But anyway, if we use the equation phi equals plus or minus delta t over the period times 2 pi using the parameters given here, we end up with V7 is 2 sine 2 pi 1000 t plus 0.2 pi radians, and V8 is 500 sine 2 pi 100 t minus 0.17 pi radians, millivolts as well. Now I think you can see why I prefer to mix radians and degrees in this form. This is much more intuitive. This, I don't know, I have a hard time wrapping my head around that real quickly. So while this is not technically correct, quite often it's done simply because degrees are so much more familiar to us. And that's all I wanted to say, and I will see you in the next video.